Man, you're on school break and you're here doing homework and coming to like daily
Yeah,
sessions.
it's crazy, right? I actually
Insurance.
have more homework than I do at school.
Really?
Like, yeah, like actually, because we don't have like homework in Poland because uh, something in the government changed and the teachers can't grade our homeworks. They can
What?
like, yeah, they can like uh, ask uh, ask us questions so we can get grades from our homework, but they can't check our homework for and give us like a grade for it.
Wow, that's very different from what I'm used to.
Yeah,
Damn, okay.
it's like crazy because this is caused by a kid who cried to a prime minister of Poland.
Wow.
Yeah, yeah.
Man.
I can like show you the video after the lesson.
Okay, yeah, sure. What the hell? Wow. Okay, so okay, I'm looking at our fold R list. Okay, so I think it's list some V2. Okay.
Right? Yeah, yeah.
Okay, so let's see our fold R. Very good. Let me run this. It should pass, right? Let me see if this language can. Let me. Let me see if I can do this. Ah, no, I can't. Never mind.
Oh,
Okay, so
okay.
yeah, that's right. Uh, list reverse V2. Hmm. Alternatively, you could also pass in add to n to list reverse V2. What you did also works.
Okay, okay.
Um, I think the time complexity between what you just did with the plus and creating the list on the spot versus add to n are the same.
Okay, right.
Yeah.
But like if we tried like making it from left to right, it would be a lot easier, right?
Ah, the idea of left to right. So that's going to be our next topic, actually.
Oh, okay.
Like how to achieve left to right and what are the techniques behind that. But okay, let's look at the rest of your stuff first. List length. Okay, yeah, that's pretty standard. Just add one.
Okay. Yeah,
Uh,
yeah. Just
list
like
contains.
before.
Okay. Um,
I did a shortcut there, right? Yeah. No if statement. If expression, right? No if
yeah.
expression.
I want to. I don't know if I want to talk about it today, but I want to talk about Boolean list abstractions at some point. You know how you
Okay.
have like more specific list abstractions like map and
Yeah,
filter.
right.
We
Yeah.
also have more specific list abstractions for Booleans.
Okay.
Um, but I think I'll save that for next time.
Yeah, of course.
Yeah. Okay. Yeah, I want to talk about that at some point. Not yet. List average, computes the average. Okay. I think this one's the same.
Yeah, it is.
Hmm. Yeah. Because it's like we are using a helper function that itself is
Yeah,
recursive. So this one
yeah,
doesn't really,
right.
yeah, this doesn't do anything interesting. Re-implement map and filter with full R.
I thought this would be hard, but it was actually pretty easy.
Hmm. Yeah, the trick, yeah, you see it like operation on X. Everything else is standard.
Yeah, I like I did like this before and it didn't work, so I thought for a second and I added this.
Hmm, very good. Returns a list containing only elements that satisfy the predicate, out filter, foldr, if
Yeah,
operation X. Yeah, standard.
yeah.
Okay, yeah, very good. Um,
I actually found the video if you have a second.
okay, sure.
I have sent you the YouTube link.
Okay. Donald Tusk.
It's our Prime Minister. It's official channel also.
What the heck? Okay. Should I share this on YouTube? Do you think is it too
No, no,
sensitive?
it's okay. It's okay.
It's okay, all right, okay. Let me share my screen on my
And because of that, we have like no grading of homework.
wait, you gotta translate for me, it's not in English.
Right, right. Uh, can you not add like subtitles?
Is that
You
captions?
can, you can. Like three dots.
Oh,
Yeah, yeah,
okay, auto translate, I guess.
yeah, yeah.
English. Oh my God.
Esperanto.
Is it American English?
No, I don't think so. It's
Where's
just
where's
English.
English?
What? No, no English? You have like
Um,
Zulu, but not English? That's no way. Maybe you have selected like English already, and
but
it's
no, it's not showing up. Wait,
there's no way. They don't want to show this to the United States, right?
guess not. I don't see it. What?
No,
This is my
it's
first time not
crazy.
seeing English. So this is how the rest of the world feels when they don't see the language they
Yeah,
need.
yeah.
Okay,
I
okay, I'll do Chinese. Let's see if this works.
Oh, hmm. Wait a minute, give me like a second, maybe.
Dude, the subtitles are not showing up. Wait, what? Titles? No, oh, it's turned off. I can't even turn it on. Dude, this is
Really?
like Polish only. Yes,
Hmm.
subtitles CC turned off.
Okay, so I can like translate it very
Okay.
quickly. Hmm. So it's like uh, it's generally a problem of Polish schools that there is like breaking the laws of the child. Uh,
Okay.
as example, the like the law to get rest, and the teachers are giving homework to the children for the weekend, and that is it. Like that's one sentence like destroyed Polish homework. It's crazy.
Dude, bro.
He said that I think like PO it's like the Polish uh, party. I don't know how to say that.
Oh, okay. Wait, when I give you homework, I'm not breaking any laws, right? I'm not gonna get arrested when I
Yeah,
hand it forward.
you won't break any laws because you are not grading it, right?
No, I'm just looking at it.
Yeah,
Wait, so kids can do homework, it just can't get graded?
yeah,
So that's even
they,
worse. That's even
yeah,
worse.
because like most of the kids won't do it, and the teachers will like ask what is in it, and they will like get grades, but they won't do homework, so they won't know what is in it.
Okay. I also feel like this kid was like a plant. Like he was planted there.
Maybe. I didn't think about it.
Okay, I don't know what's going on, man. Okay, all right, let's get back to pirate.
Yeah.
Interesting. I didn't know it was possible. I didn't know this was a thing. Well, I've out homeworked your country. I've given more
Yeah.
homework than your entire country. Okay. Yeah, okay. So Okay, getting back to list abstractions. So on a note some observations, we can implement map and filter with foldr. Now, why can we do this?
Because um, foldr is like universal and
Wait,
okay,
not
and
universal for everything, but
okay,
universal for something
okay,
specifically.
for list, and we can like turn the list into anything, right?
Yeah.
Okay,
Okay. Foldr is the most general abstraction for. Okay, I'm going to introduce a new term here. Natural recursion on lists. Natural
okay,
recursion. What is natural rec Sorry, excuse me. What is natural recursion? Remember our list template?
yeah,
We all we did was call rest on the function
mm,
on the same function.
yes, yes,
That's it's just recursion, and we're doing nothing else more than that, so it's natural recursion.
mm,
So keep this in mind for now. We're going to go into a topic where we introduce recursion that's not natural.
okay,
What does that look like? Now you'll see what it looks like.
okay.
Okay. Okay, now my question is then why should we use filter and or map and filter?
Hmm. Because we will write way less code, right?
Okay, less code to write. What else?
Uh, more the code will be more clear, right?
Yeah. I would change them a bit and say like communicates the
Okay, yeah.
intent better, right?
Mm,
Because you're saying less, so you're saying the most important parts only,
yeah.
right? Yeah.
I don't think anything else like it doesn't the same thing, but
Yeah.
written
Yeah.
more. Yeah.
Yeah. So that's actually what I want to get to talk about, which is the idea that you have less code to write and you're communicating
Mm,
what you want to communicate better. Remember last
yeah.
time I asked you to paste in the list template and fill in the holes.
Right? Yeah.
So abstraction is like the same thing, but instead of pasting in the list template, you are choosing which list abstraction to use, and to fill in the holes, you supply the arguments. You see that?
Yeah. Yeah.
So
Yeah.
yeah, like templates and abstractions, they're like the same thing, but abstractions are like something the language understands.
Right.
The template is just a tool for you for problem solving. In
Yeah,
fact,
we can't like use the template alone, but we can use the abstractions.
exactly, yeah.
Yeah.
And in fact, we arrived at the templates. I don't know if you remember this. We arrived at the templates via the abstraction recipe, right?
Yeah. Yeah.
I asked you, um, here are two functions. They look the same, but replace the parts that are different with dot dot dots. Remember that?
Yeah.
So templates and abstractions, they are like very fundamentally tied together in
Okay.
concept. And abstractions are like the conc is something that you can actually do in the programming language to manifest the template.
Yeah. Okay.
Yeah, I'm gonna say that abstractions are the abstraction, actually, I should say the process is the manifestation of the templates, with the idea of templates. Okay, so okay, I believe there is one function that we did that cannot use foldr.
Yeah, it was intersection, right?
Yeah, but that one's kind of long. Okay, I'll give you a different function to theorize about. Give me 1 second. Yep, found it. Give me one sec. Okay, so I'm going to show you a new function here. So another list abstraction is called build list. What does it
Mm,
do? So if I call build list and I pass in the function, let's say n to n, and how many? So let's say three. Oops, I forgot the n. And I hit run. Oh, whoops. What? What? Is it not called build
function.
list? Oh, do I have to import something? I think I have to import.
Really?
Whoops. Oh, I can't I can't put this in the middle of the file. I'm gonna have to put this at the top. Okay, so if you look at the results, you see it says list 012.
Yeah.
Okay, I can do something different. So let's say instead of lam n to n, I do L, lam n to n times 2, and I run. It would say 024. You
Yeah.
see that? So what is build list doing?
Uh, like building the list from zero to uh, something like the n without the n and calling like the first function on every element, right?
Yeah, on the index, right?
Yeah, on the
So it will be
yeah,
0,
yeah,
1, 2. Okay. All right. I
like
want you to try to. Okay, so here's my question for you. I'm going to comment this out. So it's not going to show up. So this is a theory exercise. Can we create build list with foldr?
hmm. We can't, right? Because you are not passing. Oh, can we pass empty list to a fold R? But hmm, what we would start with, like, uh, okay, can we do it?
Yeah, so can we?
I don't know. Like,
Okay, do you want to try?
mm, I can, but I don't know how to do that. Wait. Yeah, I don't have an idea, really.
So okay, can you try to create this function? Just like not using list abstraction, just try to write it.
Yeah, so uh, so it would be like uh, I don't know, like of course, and it would be okay, so we need x. It's not like this. It is to x, right? But it's like this. And this will create a list of type x. Mm, okay, so what do we do now? Like
Okay.
we have to like have an index, of course. to track
Okay.
where we are at. But
Okay, so which template should we use here?
oh, not the list template, right?
Okay, so when you say not the list template, we already can't use foldr, right?
Oh, right, yeah.
Okay, so yeah, that's what I want to arrive at. Okay, it is in theory possible for you to build this right now, but there's one idea I haven't introduced to you yet that you need to
Okay.
know to do this. I'm not going to go over it because I don't think it's too relevant for you, for your purposes, but I'll tell you a bit what it is. There's a thing called the number, not number, the natural number template. So this is a bit of mathematics, but a natural number is one of zero or one plus natural number. Have you seen this before?
Like I know what not natural number is, but I haven't like seen these templates, right?
Okay. So this
Mm,
is in number theory. So like mathematics, like in physics, we try to understand what makes the world.
yeah.
So mathematicians do the same thing. What makes numbers? So one way of understanding natural numbers is that it's either a zero or one more of a existing natural number. Okay.
Okay.
In computer science, this is a very important idea. I believe it's called church numerals, and it's very important to how we study programming languages and computer science through a very mathematical lens. So yeah, we're not
Okay.
going to do this because I think it's not too relevant for you. But if we use this template, what we can actually, and I'm just going to do this for you. You really don't need to know this. What we can do is we can do a conditional. So we say if num equals zero, something else if, oh, actually we can just do else. So here we may assume that number is at least zero. So if it's not zero, then it's one or more.
Okay.
What we can do is, firstly, we need to make use of this number somehow. Next thing is we should probably recur, but with one less, we pass in the operation. Okay. So assuming that
Oh,
we call
okay.
the rest of the function with increasingly
Okay.
smaller numbers, okay,
Mm,
that will give us back the proper list, right? And what can we do? What we can do is, first I should apply the operation to the existing number. We have a list and now we have X. We have to construct a list of X. How do we achieve this? Yeah, okay, let me ask you, how do we achieve this? How do we combine the two?
uh, with like link, right?
Yeah, okay.
Yeah.
Is it just called link? Oh, I just realized something. We could use link, but here's the problem. We're going to put operation num at the front of the list, but the biggest index should go to the end, right?
Right.
So we can if we use link, we have to sorry, excuse me, we have to call reverse afterwards. We could also just do
Yeah.
this.
Oh, okay.
Uh, at position zero, we just do this, but we still have to produce a list, right? So that's not completely correct. So we do this. You see that?
Yeah.
Um, you could also another way of doing this is also just the empty list here. But I don't
Hmm.
like this because it's betraying the template a bit, right? Negative one is not a natural number.
Okay.
So two ways of doing it. I personally prefer this way. I think it communicates the idea better. Okay. But yeah, again, you don't really need to know this. I'm just telling you this for your benefit. But if we look at this, we can see that we're not acting on the template. We're not acting on the list. We're acting on natural numbers, and so we
Yeah.
can't use foldr.
Okay.
Um, I will leave it at this for now. I'm going to comment this out. So again, just want to emphasize the idea that the foldr only works for the list templates that we've learned. Anything beyond that, it does not work. And this is an example of that.
Okay, okay.
Okay, I think it's time to move on to our next topic. So,
Yay. Can you like save the file because I have in line 900 902 I have like only F. I don't have like I before the F. I have fnum equals 0.
oh, okay. I'll save the file. I just saved it. Does it save on your
Uh
end?
yeah, it does. Yeah.
Okay.
But
Let's just create
I
a new
still
file.
I still
Just do
have
not
it.
mess with
Can
this.
you like okay, yeah, of course.
Yeah, I'm gonna create a new file. Call it X. I think you can guess what do you think X stands for?
Egg,
Yeah, ACC.
I don't know. I don't know.
Okay, good, good, good. So go to the new file, and we're gonna begin
Yeah.
our next topic. And this topic is called the loss of knowledge.
The loss of knowledge.
The loss of knowledge.
It's
Okay,
like a game title.
yeah. Oh, I do game development. Yeah, so yeah, I
Yeah.
like to give my session titles very dramatic names. Okay, so I am going to copy over one of the functions you wrote. Let's say I'm gonna take list sum. I'm gonna take list sum,
Of course.
and I'm gonna bring it here. So let's say we have a list of, I'm just gonna write as a comment. Let's say we have a list of one, two, three, and we call list sum on it.
Yeah.
Okay. When we recur, so on line 12, list sum rest, that's called a recursion, the recur. When we recur on the rest of the list, so just two, three, do we does the recursive call know about the one?
Hmm. No, it doesn't, right?
Why
It
not?
doesn't. Hmm. Oh, wait, wait. No, it's only like a variable to it, right? Like to
Um,
the one.
Not a variable, but
Hmm.
so what's happening here is when we call list sum two, three, does the
Right.
recursive call list sum doesn't know about the one anymore. It's forgotten. But the one is sitting outside of it, waiting for the recursive call to finish its
Yeah,
computation
to
and add
end,
one to
right?
it.
Yeah.
Yeah, so it's waiting. And the consequence of this is we get something like, let me shorten this. And I think I showed this quite a while back, but we're gonna go back to this idea. You remember this?
Yeah.
So there are two observations here. First is that in a recursive call, the elements before it are forgotten.
Yeah. Okay.
Second idea behind this is we're going from right to left. The addition happens from right to left. We add two, three first, and then we add the one.
Yeah.
Meanwhile, when we see the one, yeah, even though we see the one first, the one is waiting. When we see the two is waiting, right?
Right.
Okay. So this is natural recursion. I talked about this just now. So it's obviously recursion. Why is it natural? The idea is natural is because when we make the recursive call, the recursive call is like fresh. It's new, like we're
Okay.
not passing information to it. It forgets everything before it. Okay.
Okay.
Now, this loss information is with natural recursion, information is loss. In this case, in line 21, the one is loss. This can be a good thing. In our case, it simplifies computation. We can think about less things. It's like, oh, let's
Yeah.
forget the one. Our problem became simpler. This
Yeah.
can also not be a good thing.
Okay.
So I'll give you an example. Let's say we are an engineering company and let's say we have a bunch of line segments. Okay. And let's say
Yeah.
there are lengths to this. So like let's say that's 50, this 30. So this is relative distances, right?
Yeah.
What happens if I want to say compute the absolute distance from the leftmost point? So in our case, this becomes uh this 50 becomes 70 because 20 plus 50, and then this one becomes 100. You see what's happening?
Yeah. Yeah. Yeah.
Okay. Can you implement this using what you know so far?
Can I? I cannot
No, no, you
because
can. You can.
can I?
Trust me, you can. Using what you know so far, it is possible to implement this.
Can I do it like in for R like fold R,
Yes,
right?
you can. It's
Yeah.
possible.
Do I do it?
Yes.
Okay. Okay. So function calculate quite a long name for for a function. Um, Distance would be a list of numbers. And you can number like this. Right, right. Mm, okay. How do I do this? So we must, of course, the cases, right? Uh, it's this. And something. Uh, hmm. Hmm. Okay, but wait, wait. Hmm. I have an idea. It can be stupid, but can we like reverse the list before doing the calculation?
Can you show me?
Like, can I like implement the function from the sunset?
Sure. You can copy anything over from
Okay,
Sunset.
okay. Reverse. I will copy the folder also. Where is the folder? Uh, okay. Mm, I will, like place it here, but okay. And also reverse. Uh, Edit the reverse. Okay. So like, hmm. Okay. So
Okay.
Okay. Uh, and then we must by cases, well, doing foldr, right? Mm. So the listener was the distance, uh, distance, and the operation. What would be the empty of operation? Like, uh, what is the base? Base. What is the base? Empty words, of course. Mm. It's- okay, okay. So it's going from the top right and oh. Mm. Oh. Okay, okay. So it's like the distance and the rest.
Oh, this session's gonna expire. I have to send you a new link on Zoom
Yeah,
on Gmail, okay?
of course, right?
Oh.
Mm, okay, but we're going from like top right. Oh, right. Will be like this. It's also a list of numbers. Uh, yes. And it's empty. The last one is empty. You just just will just do this. This list of D, right? And this is not so it's the I don't know. Mm, I can call it first and rest. I can change them afterwards. Mm, it will be a link of uh, our Q1 distance, distance, distance plus first and no, not the rest, but no, yeah, the rest. Mm, okay. Did I do something wrong? Oh, I must end the lambda that this and okay. And it's reversed now, right? So it won't work if I do this right again. And then just call for sure it won't work. Yeah.
Let's have some tests as well.
Yeah, of course. Mm, so distance of I don't know. Mm, I can just call uh, 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 So, 20. uh, mm, oh, oh, what is wrong here? I highlight text.
After lam parentheses, you need to put a colon. So at the end of line 60, there should be a colon.
All right, right. What? Oh, I didn't close the brackets.
That's not where it should go.
Yeah, yeah, of course. Yeah.
Nice. Okay.
Oh, right. Is like my concept correct? But
I know
I
what you're trying
think
to
so.
do, yes.
Yeah,
Some execution needs to be fixed.
yeah. Who created this language?
A few people. It's like a collaboration between multiple people and professors from multiple institutions. Like Brown, I know is one of them.
I don't know who that is.
Oh no, Brown University.
Yeah, still no clue.
Okay, never mind.
I hate those people. Really. Uh,
No, no, Brown University, it's a university, it's not a person.
yeah, I know that, but
Okay.
uh,
Wait, do you see the problem?
mm, yeah, it's returning like twice. Yeah.
That's one of the problem. The second problem is distance is you have two local variables called distance.
Oh, oh,
You gotta give
okay.
them different names.
Really? Uh,
Okay. Notice the our folder, the computation is being thrown away.
mm,
Right? It's like we're doing a lot of work and then we don't use that work.
yeah.
Okay, how do we fix
Okay.
this?
How to fix this? Uh, oh. Can we have like an empty list and we'll add to it?
You could also save the entire computation of our folder, that's line 60, to a variable, right? And use that later.
What?
Okay, let me
How?
put this in a different way. Line 66, you're reversing
Yeah,
distance, right?
yeah,
So line 59, line 66, isn't it funny? You reverse the list and then you reverse it back.
yeah.
Okay,
Okay.
so how do we
So
fix this?
we are not doing like anything right.
Exactly. Currently, no.
Hmm. How to? Oh, how to like call it on? Uh. Oh, okay. So. Can I do like can I do it like this?
Yes, yes, you can.
Really?
Yeah. I mean, why not, right?
Hmm. Also, right.
Okay.
It's a problem with the list sum because we don't have
Oh.
like num list, right?
Oh, yeah, you know what? I'm just gonna let's just delete the test for this sum. The test exists for the previous uh yeah.
Can I comment it out?
Yeah, sure.
Yeah.
There is a way to import the file, but I don't want to deal with it now.
The name, what I'm doing is,
Nice. Okay.
yeah.
Oh, only one
One
failed.
one test failed. The empty. Yeah, it's not. Is it empty? It is. Hmm. No, no, the first one failed. Okay. 30, 80, and 100. Ah, that doesn't sound right. That sounds really wrong. What did I do? Hmm. Yeah, yeah, okay. Okay, okay.
Oh, excellent.
Uh, it
Okay.
was that easy, right?
I want to do a side tangent real quick. So line 60 to line 65, I
Yeah.
feel like the lambda really should be its own function.
Okay.
Okay, first, like, notice how it's like every other line is like one line, but line 60 to line 65 is like five lines.
Yeah.
So it's like, it's kind of ugly, right? So aesthetics is one factor, it looks kind of ugly. The second is that it's definitely more complex compared to the other lines.
Right.
List reverse is very nice and compact, but then line 60, line 65 is like, oh, it's all this showing, it's a lot of stuff here. So there's an imbalance of complexity throughout the lines of code. Um, and the thing is, I think to an average reader, they're not going to know what this does. It will confuse them. It's
Yeah.
good if this has a name. If people can see, oh, this is what the name of the function is, so I have an idea of what it's doing, right?
Okay.
Okay, so normally I would ask you to just put this into its own function, but for the sake of time, let's just move forward. If you want to do that for homework, I recommend it. You can see like
Okay.
how much cleaner the code will appear. Another tangent is naming. I feel like dist, like line 59 dist, is not a good name.
Right.
What
So, okay. So I can just call it like reverse.
you could, but then you have another reverse on line 66,
Yeah,
right?
yeah, I will change
Okay.
it. Yeah.
Okay, so you go, yeah.
Yeah, yeah.
So yeah, th this to me is a much better name. It communicates the idea better, right?
Yeah.
Okay, nice. And then how would you change line 66?
Like done. No, like
Uh, it's better, but I still don't like that.
uh final, I can call it.
Sure, sure.
I can
So this works. I personally would call it like unreversed distance.
okay.
The idea here is
Okay.
that you're reversing temporarily, right? And now
Yeah.
to for the final answer, you unreverse it. So, but final distance is also okay. Like temp, I also find that temp is not a really good name.
Okay.
Whenever
So
you have a name that can be used for anything, right? It's probably not a good name.
yeah, yeah. Uh, so it can be called
Sure,
final reverse.
sure, sure. Yeah. Okay, so this is actually one of the solutions to this. There's actually another solution. I actually find it interesting
Wait,
you found
wait,
this solution.
wait. Is
Yeah?
the ACC stand for like accumulation or something?
Yes, accumulator,
Okay,
which is commonly
okay.
used in C++, ACC.
Yeah, yeah.
Okay,
I remember it
so
now.
this is one of the solutions. I'm surprised you found this one actually. I feel like this is one of the less intuitive ones, but
Really? Okay.
yeah, I think it's because you have prior experience. That's why you came up with this.
Yeah,
Um, anyway, so I can sort of read your mind why you thought about this. The reason why is because you wanted to go left to right, but foldr only allows you to go to right to left.
yeah, yeah,
So
yeah,
you reversed it so that you can go from right to left, and then you reversed it back, right?
yeah,
Okay, so the reason why you wanted to reverse, notice it's funny wasted work, right? You reverse it, do some work, and then reverse it back. It's kind of redundant, right?
yeah.
If only there was a way to not have to reverse at all.
Wait, wait. Can I do like wait, wait. What? How do I call it? Like prefix list?
What's a prefix list?
Mm, but yeah, but we also need like a for loop for it. Yeah, and we can do that on recursion, right?
Sorry, do that on what?
But I wanted to wait. It's just yeah. Sorry, my bad, my bad, my bad.
Okay.
It
Um,
it's what it does really. Yeah,
okay. Okay, and
it is
anyway,
what it does.
the
Okay.
key idea here is that naturally information flows from left to right, but we don't have any way of encoding that in the code we write.
Right.
We
Yeah.
can't go from left to right. It's almost as if we want to, when we see the 20, we want to remember we saw that 20. So, and
Yeah.
then I'm using an example on line 50. When we see that 50, we want to remember we saw that 50 as we do the recursive call.
Yeah.
So what we want to do is we want to fight against the loss of information, the loss of knowledge, right?
Yeah.
So
Yeah.
you actually did this accidentally in the past, so I think you already know this, but I'm gonna demonstrate explicitly. I'm gonna show you a different way of solving this. So I'm writing on the last line, and we have like 4 more minutes. I don't know if I can finish this. I might ask you to finish it for me if I can't finish it in time.
Okay. Of course.
And then I'm gonna steal your tests.
Oh, you thief.
But I have to do V2 here. So you already know local functions. So I'm just gonna do this. Oh, I call this distance 0. So I'm not gonna explain much yet. I just wanna give you the idea.
Okay.
So here I have an accumulator called distance so far, and I have a variant of the same function but with an accumulator. I'm gonna pass in distance 0. And this accumulator represents the distance so far as we travel from left to right. So initially it's gonna be 0 because we traveled nowhere.
Yeah.
Okay. Then this is gonna be the list template on distance. So we're gonna do this. And then what's the syntax again? We use the bar. If it's empty, um, so if we reach the end of the list, what should be the answer?
Uh, like the uh the distance, right? The distance.
Remember, what's the resulting type of this function?
At least. Oh, okay. Okay. Sorry. So
Look at our test cases. When we give it empty, what should we get out?
empty. Okay. Okay.
Okay,
Okay.
so this is why it's
Okay.
important to write
Okay.
tests ahead of time.
Yeah. Yeah. Okay. Okay.
The other case is, was it link? It was, right? Okay.
Yeah.
So we have the first and we have the distance so far. And what we do is we accumulate the distance so far into the current
Um, okay.
value, right? Next, we
Okay.
make the recursive call to the rest of the list, and distance so far increases by f, right?
Right.
Oh, crap. What did I? Oh,
Uh,
missing parentheses. Okay. You see it?
yeah.
So I can't
Okay.
do any explanation right now. We're out of time, but I want you to internalize this.
Okay. Okay.
I don't know. I don't want to give you homework yet because, okay, no,
Yeah.
very quickly. Okay, no, so an accumulator, and I'll explain more in detail tomorrow. I'm going to give you an accumulator recipe. What does it represent? What is its initial value? How does it change? How is it useful? Whenever you use an accumulator, you must answer these four questions, and I want you to write it as a comment. I want you, at the very least, apply this to some list, reverse, uh, and any other function you have done in the past that you deem fit for an accumulator. And I'll explain more in detail what's happening, but I'll let you do this for now. Okay? All
Okay.
right. I
Okay.
do have to end here. I have another session to run.
Yeah. Of
So I'll
course.
see you next time.
See you tomorrow.
All right. Bye-bye.
Bye.